So today we are going to discuss about various anti-nutritional factors, radionuclides, and toxic trace elements. We are using a number of chemicals in foods intentionally, and sometimes even unintentional incorporation of chemicals have been seen there in the foods, and they may cause health hazards. Sources of contamination will certainly include various food additives which are intentionally added to different food materials during processing or preparation to have a certain desired effect in the prepared food products. Various chemicals used in agricultural production, from seed dressing to finally harvesting, for example, fungicides, insecticides, pesticides, etc. There are also accidental contaminants during food processing and radioactive fallout. So these will play important role as a source of contamination in the food products. First of all, we are going to discuss about various anti-nutritional factors. What are these anti-nutritional factors? These are those biological compounds present in human or animal foods that reduce nutrient utilization, thereby contributing to impaired gastrointestinal and metabolic performance. Anti-nutrients may be natural or synthetic also, that interfere with the absorption of required nutrients, be it macronutrient, for example, protein, or micronutrients, including different minerals, which we will study in detail today. Many foods, specifically of plant origin, have wide range of various anti-nutritional factors inbuilt in these foods, which interfere with the assimilation of various nutrients contained in them. Important anti-nutritional factors include trypsin inhibitors, phytates, oxalates, tannins, lectins, and goitrogens. All of them interfere with the utilization of other nutrients like proteins, minerals like iron, zinc, calcium, and iodine. Anti-nutritional factors certainly reduce digestion and utilization of nutrients by binding these nutrients and may produce other adverse effects. Common symptoms exhibited by a large number of anti-nutrients in the body include nausea, bloating, headaches, rashes, and even nutritional deficiencies, which are otherwise caused by absence of required nutrients in daily diet. But here, even if these nutrients are present in the foods, they are bound by these anti-nutritional factors, causing their deficiency. First of all, we will discuss about trypsin inhibitors. You know very nicely what is trypsin. This is proteolytic enzyme required for digestion of proteins in small intestine. This trypsin inhibitor is basically proteinaceous in nature and is present in large amount in various legumes, specifically in soybean, lima bean, and kidney bean, and also in egg white. These trypsin inhibitors anti-nutrients certainly competes with proteins to bind to trypsin. They inhibit the activity of trypsin in the gut and interfere with digestibility of dietary proteins and reduce their utilization. They are basically heat labile in nature because it is proteinaceous in nature, and you know protein is certainly heat labile because at higher temperature it will get denatured. So it is heat labile, and the extent and ease of heat inactivation varies from one trypsin inhibitor to another. It has been observed that autoclaving at 120 degrees centigrade for 15 to 30 minutes inactivates almost all trypsin inhibitors, thereby improving utilization of protein present in these foods. Even boiling of soybeans for 14 minutes has been observed to inactivate about 80% of the inhibitor, and if boiling is done for 30 minutes, about 90% of this inhibitor is destroyed. Now let us talk about phytate. Phytate is also widely distributed anti-nutrient. It is widely distributed in seeds, grains, nuts, and legumes. Specifically, unrefined cereals and millets are the richest sources of these phytates. They store phosphorus as phytic acid in their husks in the form of phytate salt. Phytate is a hexaphosphate of inositol, which acts as a source of bound phosphorus and provides this phosphorus to the seeds, which is required during germination of seeds. Phytates have strong binding affinity with iron, zinc, calcium, and magnesium, which results in highly insoluble salts like iron phytate, zinc phytate, calcium phytate, and magnesium phytate, which is poorly absorbed by the gastrointestinal tract, and this leads to lower bioavailability of these minerals because of its binding with this anti-nutrient. Phytate content reduces due to enzymatic breakdown of phytate during germination of grains as it supplies phosphorus for germination, which is required during germination. So, improved mineral availability, be it iron, zinc, calcium, or magnesium in germinated grains, can be partly attributed to a reduction in the phytate content during germination. Next comes tannins. So tannin is anti-nutrient factor, but it has one positive role also to act as antioxidant. This is exploited in food industries for various regions, in various food products because of this antioxidant property of the tannin. This is major group of antioxidant polyphenolic compounds and widely distributed in plant kingdom. This is present in high amounts in seed pod of most legumes, spices, tamarind, turmeric, green tea, in certain vegetables and fruits like grapes. Even millets like bajra, ragi, sorghum, etc. contain a fair amount of this tannin. This tannin binds iron irreversibly, therefore interfere with its absorption. It is also known to bind proteins and certainly leading to reduction in its availability. Next comes lectin. Lectin is present in various vegetables like tomatoes, potatoes, peppers, and eggplants, and in legumes like lentils, beans, and chickpeas, peanuts, peanut-based products, peanut butter, and peanut oil. All of them contain lectin. Lectin has been observed to cause flatulence. So, consuming legumes and grains in their raw form leads to nausea, diarrhea, and vomiting. And it has been observed that this lectin content of food products is inactivated by heat and fermentation process. Next comes oxalates. Oxalic acid forms soluble with potassium and sodium, or insoluble salts with calcium, magnesium, and iron, or esters, which is known as oxalates. These oxalates are widely distributed in various green leafy vegetables, green vegetables, and also in some legumes. This specifically interfere with calcium absorption by forming insoluble salts. Insoluble salts cannot be processed out of the urinary tract once processed through the digestive system. Calcium oxalate can have a deleterious effect on human nutrition and health by accumulating as kidney stones. Some patients are advised to avoid high oxalate foods. Most people can induct normal amounts of oxalate-rich foods, while people with certain conditions such as enteric and primary hyperoxaluria need to lower their oxalate intake from different food materials. In sensitive people, even small amount of oxalates result in burning in the eyes, ears, mouth, and throat, whereas large amount of oxalate consumption results in abdominal pain, diarrhea, nausea, and muscle weakness. Next comes goitrogens. This disrupts the production of thyroid hormones by interfering with iodine uptake in the thyroid gland. Goitrogens triggers pituitary to release thyroid stimulating hormone, which promotes the growth of thyroid tissue, leading to iodine deficiency goiter. This is present in ample amount in various leaves and vegetables like cabbage, cauliflower, radish, rapeseed, mustard, soybean, peanut, lentils, etc. Thiocyanate, isothiocyanates, and their derivatives are important goitrogens present in these leaves and vegetables. Thus, we have seen that these anti-nutrients interfere with proper digestion and absorption and availability of protein as well as different minerals. But one important thing is that various traditional methods of food preparation has been observed to reduce certain anti-nutrients, thereby resulting in increase in the nutritive quality of the various plant foods. For example, soaking in distilled water with 1% sodium bicarbonate and mixed salt solution has been observed to reduce total phenols, tannins, and phytate content of various foods by 33, 35, and 21% respectively. Similarly, fermentation of the food, specifically assorted grain flour with Lactobacillus acidophilus at 37 degrees centigrade for 24 hours has been observed to result in reduction of phytic acid and polyphenol content. Germination, which is also one of the most effective process, naturally result in reduction of phytate content as it utilizes phosphorus of the phytate during germination process. Heating means cooking whole grains, beans, and vegetables also reduces phytic acid, tannins, oxalic acid, and protease inhibitors. Now we will discuss about various radionuclides. Radionuclides are nuclides with an unbalanced and unstable nucleus. This you know very nicely. It is an atom with a defined atomic number and a defined neutron number, and this number of neutrons determines whether the nucleus is radioactive or not. For the nucleus to be stable, the number of neutrons should be, in most cases, a little higher than the number of protons. If the number of neutrons is out of balance, the nucleus has excess energy and sooner or later will discharge the energy by decay processes, that is, by emitting rays or subatomic particles. A nuclide with such an unbalanced nucleus is unstable and is called a radioactive nuclide or radionuclide, which may occur naturally, but they can also be artificially produced. So radioactive atoms that has excess nuclear energy is certainly unstable, and to come to more stable form, they will certainly emit various radiations as they undergo radioactive decay through the emission of alpha particles, beta particles, or gamma rays. These radioactive atoms emit radiation at its own specific rate, which is measured in terms of half-life, which is the time required for half of the radioactive atoms present to decay. In living tissues, they can lead to development of cancers or even genetic abnormalities. For example, strontium-90, cesium-137, iodine-131, and carbon-14. Here, let us see nature of different radionuclides. Alpha particles consist of two protons, which is certainly positively charged, and two neutrons, whereas beta particles are negatively charged electrons. Gamma rays are electromagnetic radiation having no charge, and neutrons are subatomic particles without any charge. Sources of radionuclide contamination include naturally occurring radionuclides like potassium-40, uranium-235, thorium-232, carbon-14, beryllium-7, hydrogen-3, and rubidium-87. Even burning of coal and oil have been observed to lead to the distribution of potassium-40, bismuth-21, rubidium-214, radon-222, and radium-226 into the biosphere in the form of smoke and fly ash. This disseminated material present in soil is incorporated into the plant from soil and eventually in grazing animals, coming to various animal products, be it milk or meat, and finally it reaches to man. Second source is testing of nuclear weapons. Nuclear weapons tests release large quantity of plutonium, strontium-90, and cesium-137. And next is operation of reactors of all kinds and the application of atomic energy in medical, industrial, and scientific usage. Ground testing of fission or fusion of nuclear testing results in widespread distribution of many different kinds of artificial radionuclides also. For example, strontium-90, strontium-89, barium-140, cesium-137, iodine-131, calcium-91, and other less familiar radio elements. The actual steps utilized certainly depends upon the mode of contamination, the chemical and physical characteristics of the radio elements, and the dietary patterns of the human population involved. Not all of these pathways will be involved in the dissemination of any one particular radionuclides. Let us see radiological properties of some of the radionuclides. Here you will see half-life, specifically for iodine-131. It is having very short half-life, that is 8.05 days only, and emit G energy that is 0.36 million electric volt and B energy as 0.61 million electric volt. Cesium-137 has very long half-life, that is of 30 years, emitting G energy as well as B energy, whereas cesium-134 has very short half-life comparatively. This is 2.06 years, emitting G particle as well as B particle, gamma rays and beta particles. Strontium-90 is having very long half-life, that is 29.1 year, and this is emitting only beta particles, that is having 0.55 million electric volt. Now let us see one by one various nucleotides, radionuclides. First of all, let us discuss about strontium-90, which is having half-life of 29 years and is beta emitter. Chemically, it is similar to calcium, so it is normally present in greatest amounts in calcium-rich foods. It is treated by the body in the same way as calcium, and ultimately, certainly it will find its way in bone structure with calcium. So grazing animals can ingest strontium-90 from contaminated grasses, and this will be concentrated in their bones, and cow's milk also contains some of the strontium-90. Then from milk, it comes to human diet, and it is accumulated in bones of human beings, specifically children. Because of radioactivity, it will lead to bone tumors and leukemia. Children are naturally very sensitive because they require large amount of calcium and takes lots of milk. So bone formation is very actively taking place in children, and as a result of this strontium-90 will deposit relatively more in children. They also face a longer lifespan, so important because of radiation effects are cumulative. Next comes cesium-137. This is having half-life of 30 years, and it is G emitter. This is an alkali metal and similar to sodium and potassium, and so its compounds are absorbed by the body in the same manner as sodium compounds. Absorbed cesium-137 is accumulated in soft tissues of the body of human being, and it may cause genetic harm. It is not retained in the body for a long time. Next comes iodine-131. It is Bg emitter. This iodine-131 accumulates in thyroid gland and attains its high concentration isotope of iodine-131 is considered hazardous because it produces intense radiation. However, it is having very short half-life. So after serious fallout only, it is going to create problem. Soil pathway is almost non-existent because of the short half-life. Major movement is from atmosphere to vegetation to dairy cow and through milk to man. Next is carbon-14. Explosion of nuclear weapons results in carbon-14 in the environment, presence of carbon-14 in the environment, which in the course of time is converted into carbon dioxide, and by the process of photosynthesis, this carbon-14 is incorporated into various plant tissues, which may be eaten by either man or by animals, and then if man consumes these animals as a meat or in the form of milk, this carbon-14 will find its way into various organs of the human being. Carbon-14 decays very slowly and remains radioactive for thousands of years. So modern nuclear bombs have been observed to release into the atmosphere a much smaller amount of harmful radioactive isotopes than the original types. Nevertheless, contamination of atmosphere still occurs when such bombs are exploded. So, testing of nuclear weapons must be avoided. While contaminant radionuclides can and do reach man by many different foods and pathways, Milk is found to be a major contributor to the uptake of the fallout nuclides, which is considered to be most hazardous to man, specifically strontium 90, cesium 137, and iodine 131. Discharge routes for radioactive wastes from a nuclear site can be liquid, gaseous, and solid. The aquatic pathway covers potential contamination of oceans, rivers, and lakes due to liquid discharges. The terrestrial pathway deals with potential contamination of land, predominantly due to gaseous discharges to the atmosphere. For terrestrial radiological monitoring programs, cow's milk is often the predominant sample taken because it is readily available, consumed by a large number of people, and is a good indicator of radionuclide present in the environment. Now comes toxic trace elements. You know, essential trace element is a dietary element which is required in very minute quantity for growth, development, and physiology of the organism. Some of them are also required to play vital metabolic activities in organisms. For example, iron, which is important part of hemoglobin, copper, required for respiratory pigments, cobalt, a very important part of cyanocobalamin, that is vitamin B12, manganese and zinc, which are required for proper functioning of various enzymes. Cobalt, copper, fluorine, iodine, iron, manganese, and zinc. These minerals are also essential in very minute amount, very little amount, but if they are taken in very high concentration, they will lead to toxicity. But some of the elements like lead, mercury, cadmium, arsenic, etc. have no known biological function and leads toxic effects even at low concentration, and have been observed to be a threat to our foodstuffs by virtue of industrial usage. First of all, let us discuss about lead, which is used in batteries, paints, alloys, and as anti-knock in petrol, and leads to environmental pollution. Even fruit juices kept in lead-containing glazed pottery can pick up lead because of its acidic nature. Well, most important thing is that cow has been observed to act as a very effective biological filter, diverting lead from her feed to her bones rather than to her milk. Even crops grown near busy highways have been observed to contain high lead content, which has been reported to exceed even 100 ppm in the dry matter. And it is estimated that nearly 90% of the ingested lead is derived from foods we eat, out of which only 5% amount is absorbed. This is good that very less absorption is there, but that is also toxic and leads to mild anemia, kidney damage, mental deterioration, and aggressive behavior in human beings. Next comes mercury. Various industries, for example, chlor-alkali industry, which uses mercury for preparation of electrolytic cells, pulp and paper industries, where mercury compounds are used as slimicides, and in agriculture, these mercury compounds are used for seed dressings and various sprays, etc. They release this mercury compounds in the environment, leading to pollution of the environment. Even mercury is converted in sediments on river and lake bottoms into highly toxic methyl mercury compounds. This is cumulative poison which is stored in liver and kidney of human being. Pure metallic form of mercury has been observed to be very poorly absorbed, and it is readily excreted from the body, so unlikely to cause poisoning. But the inorganic and organic mercury compounds are highly toxic to human beings. Clinical symptoms depend upon the type, dose, method, and duration of exposure to mercury compounds. Most common cause of mercury poisoning is consuming too much methyl mercury or organic mercury, which is present mostly in the seafoods, that is fishes, shellfish, etc. Methyl mercury accumulates in human brain, so it has been observed to be neurotoxic, leading to sensory disturbances in the limbs, the tongues, and around the lips. It creates irreversible damage to central nervous system, leading to ataxia, tremor, slurred speech, tunnel vision blindness, loss of hearing, and ultimately death. Minamata disease of Japan has been observed to occur because of consumption of mercury contaminated fish and shellfish present in Minamata Bay. And the causative agent is organic mercury compound, which comes from various chemical industries in the Minamata Bay. And finally, it is available in fish and shellfish present in that bay. And consuming these fish and shellfish leads to this disease in Japan. Next comes cadmium. Cadmium toxicity occurs in persons who breathes in high levels of cadmium from the air, or eats food or drinks water containing high levels of cadmium. This is also present in the environment as a mineral combined with other elements like oxygen, chlorine, or sulfur. Cigarette smokers increase their intake by about 25 to 50%. Threat to milk comes from forage and fertilization of feedstuffs with the sewage sludge. Cow acts as effective biological filter, and the proportion of ingested cadmium finding access to milk is extremely small. Clinical symptom includes that most of the absorbed cadmium from the diet is retained in the kidneys, and long-term chronic ingestion of this mineral causes serious renal damage and also bone disease, leading to brittleness and even collapse of the skeleton. Abnormally high levels of cadmium results in several types of cancers. Cadmium toxicity is the prime cause of Itai disease present in, observed in Japan. Next comes arsenic. It is a metalloid which is having properties of both a metal as well as a non-metal. Most toxic inorganic compounds are arsenic trioxide and arsenic pentoxide. Major source of arsenic is copper smelting and low-grade coal combustion. Even herbicides, burning of firewood and cow dung leads to environmental arsenic pollution. Inorganic and organic arsenic compounds are absorbed from the diet, and through bloodstream it reaches to different organs in the mankind. Chronic arsenic poisoning leads to general muscular weakness, loss of appetite, nausea, and inflammation of the mucous membranes of the eye, nose, and lungs. That's all about anti-nutritional factors, radionuclides, and toxic trace elements. Thank you. Thank you very much.